Option is option B.
Priority queue is implemented as a max heap. Initially, the level order traversal of S elements of heap is 70, 50, 30, 20 and 10. The new elements 349 are inserted in a heap. There are two elements inserted, new elements, that is 3 and 49. The level order traversal after the insertion. We need to find out the level order traversal after the insertion. So first of all, let us do with a heap. What are the elements initially? Max heap means always the root node should be higher. So 70, next 50, because the given order is 70, 50, 30, 20 and 10. Next 50 we will insert here, because we will complete this. It is a complete binary tree where all the elements are inserted level by level in a complete fashion. 70, 50, next is 30, next is 20, we will come here again for 20, again 10, we will insert the 10 here, because that is a complete binary tree. We have to finish each and every node first. Now we need to insert 3 and then followed by 49. After inserting 3, the tree will be like this. After inserting 3, the element 3. So it can be 70, again 50, again 30, again 20, again 10. This is a present situation. We have to insert 3 for this. 3 we can insert on the left side of 30, because in order to complete this route we need to insert here. But the condition is the leaf node should be less, the child should be less than the parent. Again we have to insert 49. So actually we have to insert 49 here in order to complete this loop, this particular level. In each level you have to finish, but this 49 is more than 30. That's why we have to swap 49 and 30. So 70, again 50, again 49, because this 30 and 49 will be swapped. This 20 and 10 will be as it is. So after swapping, the 30 will go here and 49 will come here and 3 will be as it is. So the level order traversal means level by level we have to read the contents of this node. So 70 is first in this level. In this level 50, 49. In this level 20, 10, 3 and 30. So it will be 70, 50, 49, 20, 10, 3 and 30. It is equivalent to option D. That is a level order traversal, just like a BFS traversal.
A graph is given and we have to find the breadth first search for the given graph. BFS is a graph traversal technique and it begins at one node and explores all the neighboring nodes. So here we have to start from vertex A. So if we start with vertex A, the nodes which are neighbors, which are adjacent to A, vertex A, are explored first. So here B and C are adjacent to A. So here B and C are visited. Now the nodes which are adjacent to B are visited, and later the nodes which are adjacent to C are visited. So here the nodes adjacent to B are A and D, but A is already visited. So remaining is D. So D is visited. Now the nodes which are adjacent to C, here A and E are adjacent, but A is already visited. So E is visited. Now the nodes which are adjacent to D are visited. Here B, E are adjacent to D, but they are already visited. So hence they are not visited once again. Here nodes which are adjacent to E are C and F, and C is already visited. F is not visited. So F is visited. So here BFS is A, B, C, D, E, F. So here correct option is option D.
The following statements, there were two statements given, statement S1 and S2. S1 is indirect process communication can have more than two processes for each link. Statement S2 is a mailbox communication is nothing but a direct communication. Which one of the above statements is/are true? So let us see the statement S1. We need to find out the true statements. Indirect process communication can have more than two processes for each link. So this is a true statement because indirect communication is nothing but a mailbox communication. The sender can send a message to mailbox and the receiver can receive a message from mailbox. Let us suppose P is sending a message to a mailbox A and Q can receive the message from mailbox A. That means P and Q are connected with a link via this mailbox A. And statement S1 says that indirect process communication can have more than two processes for each link. It is possible because if P uses the same link to communicate with R also, that means P can send a message to A and R will receive a message from A. That means out of this link A, the link is established if they have shared mailbox. So P and Q are communicated via the shared mailbox A, that is one link, and P and R is also communicated via the same link, but the number of processes are 3. So statement S1 is true. S2, a mailbox communication is nothing but a direct communication. It is wrong. Just now we have seen that a mailbox communication is a indirect communication. It is not a direct communication. Only S1 is true. Option B is the right option here.
Here in this question, relation R with its FD set is given and we have to find the highest normal form achieved by that relation. In order to solve this problem, first of all we need to find out the keys for the given table. So here given table consists of attributes A, B, C, D, E and F, and FD set is given. So let us find keys for this table. So if you find A plus, we will be getting, that means A closure will be getting A, B, C, D, E, F. So here A can derive all the attributes of the table. So one of the keys would be A. And if we find BC plus, BC closure will be getting BC, A, D, E, F. That means BC is also deriving all the attributes of the given table. So here one more key would be BC. So let us find B closure. If we find B closure, we will be getting only BF. So that means we cannot take B as a key, and we cannot take even D as a key. So here only two keys are there. They are A and BC. And if we see the functional dependencies given, here there is a partial dependency between, in FD B gives F. Why? Because here B is part of the key. Why? Because BC is key. So here B is part of the key, deriving one non-key attribute. If there is a dependency between part of the key and non-key, then that is partial dependency. So here one partial dependency is there. So here this functional dependency violates 2NF condition. In 2NF there shouldn't be any partial dependencies. So here partial as there is a partial dependency, it is not in 2NF. It is not in 2NF. So here correct option. So here the highest normal form achieved is 1NF. So here correct option is option A. In this question,